Imagine you're learning to ride a bike. You start with training wheels and gradually learn to balance on your own. Let's go. Machine learning, ML, is teaching computers to learn from experience, just like how you learn to ride a bike by practicing. Instead of programming every rule manually, you give the computer examples and let it figure out patterns on its own. If you show a computer 1,000 pictures of cats and dogs, it can learn to tell them apart without you explaining what a tail or whiskers are. In supervised learning, the computer learns from labeled examples, like a teacher giving answers. For example, predicting house prices. You give it data like square feet, price, 1,000, 200,000. The computer learns the pattern, like bigger houses cost more. There are two main tasks: regression, which is predicting a number, and classification, which is predicting a category. In unsupervised learning, the computer finds patterns in unlabeled data with no teacher, just exploration. For example, grouping customers by shopping habits. The computer might discover groups like budget shoppers or luxury buyers without being told what to look for. Common tasks include clustering, which is grouping similar things, and dimensionality reduction, which is simplifying data. In reinforcement learning, the computer learns by trial and error, like a video game character learning to survive. For example, a robot learns to walk by trying different movements and getting rewards for moving forward and penalties for falling. Key terms made simple include features, which are the input details, labels, which are the output you want to predict, models, which are the brain the computer builds to make predictions, training, which is teaching the model using data, and prediction, which is guessing the output for new data. How ML works step by step starts with collecting data, like house prices, sizes, locations, etc. The rule is garbage in, garbage out. Bad data equals bad predictions. Next, you clean and prepare data by fixing missing values and converting categories to numbers. You split data into a training set, which is used to teach the model, and a test set, which is used to check if the model learned well. Then, you train the model by picking an algorithm like linear regression or neural networks. The model adjusts itself to minimize errors. After that, you evaluate the model by testing it on unseen data and using metrics to measure its performance. Finally, you deploy the model to use it in the real world, like a real estate app that predicts prices for new houses. For a simple example, let's say you want to predict pizza prices based on size. You have data showing the diameter in inches and the corresponding price. The model uses linear regression to find the best formula for predicting prices based on diameter. If the model learns the formula, a 14-inch pizza would cost a specific amount based on that formula. Common pitfalls include overfitting, where the model memorizes the training data but fails on new data, and underfitting, where the model is too simple to capture patterns. Machine learning matters because it has real-world applications, like Netflix recommending shows, self-driving cars recognizing stop signs, and doctors predicting diseases from X-rays. It's everywhere, from your phone's face unlock to chatbots. To get started with your first ML code in Python, you can predict pizza prices with linear regression using a simple script. You train the model with the diameter as features and the price as labels, then predict the price for a 14-inch pizza. Next steps include playing with data using tools like Kaggle or Google Colab, learning by doing and not fearing equations. Machine learning is like teaching a computer to learn from examples instead of following strict rules. The more you practice, the better you and the computer get. Let me know if you want to dive into any specific topic next.